Hey class, how's it going? I moved a little. I'm on the other side of the board. We got part 3 here talking about how do you understand the actual variables given in a kinematics question. How do you know, like, if you have VI, if you have VF, if you have an acceleration. So I'm going to go through 4 questions here that start off easy and get kind of a little trickier and trickier, and trying to help you understand a few of the ways to look at and figure out variables in a question. Even though when it looks like it only has 2 or maybe only 1, how do you find those 3 variables? Because again, for each of these questions, basically you need 3 variables, because then you can use one of those other formulas to figure out a 4th variable and a 5th variable. But you basically always need 3 variables, okay? So let's go through a few questions here. I'm going to look at myself here for a second, and then I'm going to go away. There we go. All right, so this is kinetic questions for helpful videos. Let's pop this up just a little here. And let's talk about some of these questions. So I got our formulas here, that way I can kind of plug and play our formulas eventually. But let's just figure out what variables we have. Okay, so for most questions I like to put this down. Okay, acceleration, time, distance, VI, VF. It doesn't really matter which order you write these, but those are the possible variables you can have. So let's look at what we have here. It says Ty is walking along the hallway, down the hallway at Murdoch McKay when he sees Abel some jelly bean food. Pretty good food. When he went from a speed of I don't know why there's 2 dots there, I'll change that, 1.222 or 1.2 meters per second to a speed of 6.8. So you can kind of guess this is our VI, this is our VF. So let's put that in right away. 1.2 and 6.8. Okay, and he was accelerating at a rate of 0.8 meters per second squared. 0.8 meters per second squared. So we already have 3. How much time did it take to reach the new speed? So I'm looking at time, there's my question mark. I really don't care about distance, so I can just get rid of distance. If you have it on your paper, usually I just kind of cross it out. I don't care about that. But we have our 3 variables, acceleration, VI, VF. What formula are we going to use? Well, basically the one that does not have distance, because that's not what I'm not going to want. So nicely, that's formula number 1. Acceleration equals VF minus VI over t. Okay, in my next video, I'll actually answer all of these questions. If I do it now, it's going to take kind of too long to go through each one. But that's an easy question. That's where my variables, I have my 3 variables. You can see 3 numbers there. So that one's not too hard. I think we should be okay with that one. Let's go to our next question. These will kind of get a little tougher and tougher on trying to figure out our variables. All right, so let's get rid of these. Distance is back possibly in the fold here. All right, question 2. Lance wants to see how high he can throw a rock straight up in the air, okay? If he throws the rock up with a velocity of 26 meters, so again, this is him throwing the rock. So this is him starting to throw the rock. And so a lot of people want to say sometimes this is a VF because that's like how high, like how fast it's going. But that's how much velocity he started to throw it with, okay? So it's going to start slowing down right away because of gravity. So our VF right away here is going to be 26 meters per second, okay? It says, how high is it after 2 seconds? Cool, time is 2 seconds. Okay, in this question though, I'm only given 2 variables. Okay, but the third one we should be able to figure out is usually not too bad. We have a variable that as soon as anything is in the air, as soon as anything is let go by me or by anyone else, there's always an acceleration of gravity on it. Okay, and that's our 9.8. Okay, now, you have to know whether it's going to be a positive 9.8 or a negative 9.8. And here's kind of what I kind of talk about. So if you are on top of a hill and you throw something over, okay, gravity is helping you in that sense. Gravity is going to make it go faster. So this would be like a positive 9.8, okay, meters per second squared. If, like in this question, you are a person who is throwing a rock straight up, okay, gravity is going to be slowing down your rock. Okay, so it is going to be a negative 9.8 meters per second squared. All right, so in this question, what my other variable is, it's going to be a negative 9.8 meters per second squared. That's my 3rd variable. What was I looking for in this question? It says if he throws the rock up with a velocity, how high? So I'm looking for a distance. So there is what I'm looking for. And I can ignore my VI. Okay? So 1, 2, 3 variables. I don't care about my VI. I'm looking for a distance. So which one basically doesn't have a VI in it? I can go with this one here. My VF squared equals VI squared plus 2AD. Okay, again, my next video I'll actually answer this question and I'll go through some of the algebra for you. Okay, but there's how to figure out your variables. And this is kind of, again, talking about our gravity. When is it positive? When it's helping you. When is it negative? When it's actually hindering you, when it's slowing down whatever you're throwing. All right, there's question number 2. Let's go to question 3. We have 4 questions to look at. So we're halfway through. Question 3. Emma is on a hot air balloon ride with Haley, and they see Alex on the ground. They decide to drop a Slurpee on him. They need a Slurpee on a hot air balloon. That's the Winnipeg thing to do. If they were 98 meters above Alex, what was the velocity of the Slurpee that hit him? Okay, so on this one, it only looks like we honestly only have one given variable. It says if they were 98 meters above Alex. So we have a distance of 98 meters. Okay, I want to make sure that VI is back in here. I'll ask a question. All right, so that's all we're given is a distance. Well, okay, again, just like last thing, at least we're dropping it. So we know that acceleration is going to happen, the acceleration of gravity. It's helping this Slurpee in this sense. Okay, it basically started above, we dropped it, so it's going to make it go faster. So acceleration is 9.8 meters per second squared. And lastly, okay, do I know what my time is? No, it doesn't. Do I know any of my velocities? Well, I kind of do, okay? If you are standing still and you drop something, okay, and this is going to be used a lot where people are dropping things. If you drop something, well, how fast did it start off with? Well, if I start like this and then drop it, okay, when it's in my hand, it is a velocity initial of 0 because it's in my hand, it's not moving. Okay, so anytime you hear the word drop, you can kind of basically automatically put a 0, okay, meters per second beside our velocity initial. So there's our third variable here. Okay. Lastly, what are we looking for? We're looking for the velocity final, like how hard did it actually hit Alex. So I don't need my time here. And so now we can figure, okay, I have an acceleration, distance, VI, VF. Where's one that has no time? This one again, okay? Same exact formula we used last one, VF squared equals VI squared plus 2AD, okay? I think the last question I might use the wrong formula, but I'll maybe go back to that. I'll make sure I answer it correctly in the next actual video. But I got the variables right in the last one. Variables are right in this one as well, okay? So we had A, this one D, VI, VF, okay? So there's the variables for this question. All right, last question. Let's look at the last question. True time equals, all right. Question 4. Mr. Westwood throws a football straight up in the air with a velocity of 25 meters. So again, this is me throwing it up in the air. I have a velocity initial of 25 meters per second. This is kind of similar to the last one, question 2. But this one just says, how high does the football actually get in the air? So this one says, yeah, where's my distance? Okay, so I need that one. Again, because I'm throwing something in the air, gravity is going to come and hold. This is slowing down my football. So we have a negative 9.8 meters per second squared. But in this one, it basically says like, okay, but I don't have a time. The last one gave me a time, so at least I could figure that out. Like, I knew how long it was going to be in the air to tell me how high it was. This one doesn't give me a time at all, and so the only other one possibly that I could figure out is velocity final. And so this is going to kind of make us think a little bit of, like, when it gets to the highest point, if there's somebody here, standing here, they throw something straight up, and let's say it gets to this height, okay? If it gets to the highest point, when you throw something up, when it gets to the highest point, what happens? Well, it comes back down after, okay? But at this exact max point, I'm going to put a max point here because we're going to use that a bunch. At that max height or that max point, what happens? Well, the ball basically stops. It goes all the way up. It stops for like the fractionest of a second, so basically 0.00001 of a second, and then starts coming back down. But at that point, we can basically say that there's a velocity final of 0. Okay, I don't care what happens afterward. I just want to know how high it got. I want to know that distance. And so for that, we can put a velocity final of 0. Okay, so I don't care about my time again. And so yes, I'm going to use this other formula again, that VF squared, VI squared, because I can figure out that I have a velocity final at the very top of 0. Okay, so there's 3 or 4 or 5 tips on when we're looking at these questions, how do I figure out my variables? Okay, there's a few different scenarios where, again, you're only going to see 1, maybe 2 numbers, But there's other numbers that you can kind of figure out because of either acceleration of gravity or because we know that when you're dropping it, VI is 0. If you're looking for a maximum height, usually our VF is 0. And so there's some helpful hints. Hopefully when you go through these questions, those will make sense. All right, thanks class. I gotta basically do this for a second. There we go. All right, have a good class, or have a good day, class.